the 7 costly and complex challenges of big data analytics. Hi, my name is Thomas Hazel, and I'm the founder and CTO here at ChaosSearch. At ChaosSearch, we transform customers' cloud object storage, like Amazon S3, into a massively scalable database, going after use cases such as observability, security, and application insights. Today, I'll be talking about the first of the 7 challenges of big data analytics. This episode will cover data pipelines, the building, scaling, and their maintenance. We will outline what they are and why they're important, but the focus will be on the problem one encounters at scale. You should see these episodes as a series where each leads into the next. Think of them as a journey, a data journey, where we'll examine everything from the actual sources generating the data to the extraction value from them. So let's get started. What is a data pipeline? From a historical perspective, pipelines can be anything that processes data that is connected in a series where the output of one element is the input of the next. One might hear of them in CPU or GPU hardware, as well as software within operating systems such as Unix-like computers, where the pipelines are used in an inter-process communication. And finally, networks. Think computer-to-computer communication, and have pipelines such as HTTP over TCP protocols. One can see pipelining is a heavily used concept. For this discussion, the pipeline is a culmination of all these aspects, where a source generating data to be sent over a network to be received by a computer application, and it's either the final destination or sent to another application within a computer or sent off to yet another computer over a network. Such a data pipeline serves 3 major purposes along the data journey. For example, the most important is the movement of data from a source to a destination. As part of moving data, the second key aspect is buffering. Think of the storage. In case the destination cannot handle a change and/or speed in the ingestion of data. It is common that physical storage is used to persist data in case a computer or network has capacity issues or some failure. We'll dive into this as we talk about data pipeline challenges in a minute. And finally, pipelines often provide preparation and enrichment tooling so that the next element in the pipeline can receive it. But once again, we'll dive into this as we talk about data pipeline challenges. From these 3 purposes, 2 modes, think use cases, are derived. The first is batch mode, and the second, real time. Batch mode is seen as moving data, think event, on a periodic basis, where more than one event or summary events is moved per interval. Real time or near real time is when events are sent immediately as they are produced. Both these modes have benefits, but also real challenges. We'll get into these challenges in a moment. The selection of a mode is often a result of the type of insights a situation has. However, there are cases where a source is the cause. For example, Internet of Things devices typically are dumb with limited capacity. As a result, data needs to be sent rapidly so that the limits of the device don't drop valuable information. However, you could imagine such devices within an ecosystem could be within the thousands, even millions, where the load on the pipeline can be immense. Now, some sources could be applications backed by a database, or a database is the source itself. In this case, such sources have persistence that can buffer data such that batch mode could be employed. It is often the case that batch mode is more scalable as it reduces the overall load on the pipeline. And yet, often is the case that real-time information is the most desirable, and thus real-time or near real-time pipelines is deployed. There are even cases where both modes leverage when a source initially sends a batch. Then, real-time events are sent thereafter. This batching can be the result of a device first coming online, but often a result of a failure for a time period in the pipeline where a bulk synchronization can be used. You can imagine the importance of such data pipelines in an organization with all the devices and services a company deploys. As a result, there are numerous products that have been built to support a variety of data use cases. Well-known solutions from companies such as Fivetran, Matillion, and new players like Cribble. There are also many open source projects such as Logstash, FluentD, and the ever-popular Kafka, to name just a few. Each one of these solutions or projects have their pros and cons. Cons typically are a result of their capability limitations or just plain cost, but they all have issues with scale. And the more scale that is required, the more cost and complexity increases. And with scale, said capabilities always begin to slow and eventually fail, failing to a point that alternative technologies and architectures are entertained. Certainly not ideal when the need for data is increasing. Rebuilding the Taj Mahal every 6 months is never a good idea. So why is scale such an issue? And really the only issue? The reason is it pushes on all aspects of the technology and architecture a product employs. Any solution at small scale can work and work well. Sure, there are some products better than others. One might simplify or streamline some aspect of the data journey. Maybe another is more cost effective, but scale always seems to break the pros a product might have. I find that companies not only have a data journey, but an architectural one as well. In other words, when a product hits limits in either time, cost, or complexity, it is end of life to be replaced by a more scalable one. Ultimately, a purpose-built, homegrown solution supported by an army of DevOps, data, and software engineers. This is often when Kafka enters the picture with a lot of proprietary work. So what's the answer in this ever-increasing data conundrum? For me and folks here at ChaosSearch, as well as our customers, is to leverage these best-of-breed solutions for only what they're good at. For instance, Fivetran, Matillion, and Cribble have hundreds of connectors to automatically pull data from very well-known applications and services. The issue is when scaling them. The problem is not in pulling data, but sending it into the next phase of the data pipeline, usually a database where the scale issues begin. This also goes double for agents, such as Logstash or FluentD, which are designed to send data directly from the source. The problem gets even worse as source schema changes, where the receiving database cannot consume the data as it cannot interpret the format change. In a perfect world, the source pullers and senders just move the data in a schemaless or opaque way and ignore the schema and schema changes and move this opaque data to a receiving database that can handle the volume and variety and velocity. However, as data increases in size and complexity, databases continue to fall behind. Now, there have been movements in new types of database architecture, but growth always seems to outpace any solution. As a result, architectures like object storage have been used as a stopgap. In other words, make cloud object storage an element within your data pipeline. It can handle volume and velocity of the pipeline in an extremely cost-effective way, where it can store data as an opaque object, giving the final destination database time to either consume the data on its own timeline or address changes in the schema. One can think of cloud services like Amazon S3 as one gigantic queue that delays insights, but this delay allows the databases to catch up. Today, this is the answer to how to scale pipelines. Yet, the real answer is not to have delays. For this delay is where DevOps and data engineers, as well as DBAs, spend weeks, if not months, trying to rebuild the teetering pipeline and associated database with new preparation and schema logic. Here at ChaosSearch, we took a different approach. leverage the powerful principles of cloud object storage, scaling the data pipeline, but instead of moving data out, leave it there and turn this storage into an actual database. Not as a slow archival backend where data is moved into more expensive caching layers such as memory and SSDs, but as ultra hot backend for a new kind of database, a new search SQL database that not only addresses the scale and cost, but addresses the proverbial schema dilemma. And this is the perfect segue into our next episode, the challenges of data preparation. See you next time.